All right. Good morning, good afternoon, good evening. This is the Architect Podcast. Thank you for joining another Saturday morning, beautiful Saturday morning. It's July 12th. And I hope you all are having a great summer so far, wherever you are in the world. So, today we're going to really focus on integrating tools that are commonly used out there, right? Tools like AnythingLLM, uh, N8N, FlowiseAI, etc. I've talked about some of these tools in the past, and I showed you some demos around that. But how do you use that in connection, right, in integration with Nutanix Enterprise AI? And I think that's extremely important. And the reason why is because these are tools to really get your mind going around the possibility of what you can bring to bear. In the last episode, it's been a while, and I apologize. I had a little break there, but in the last episode, we definitely talked about getting from ideation to business value. And this is going to be almost like a series, right? Because the last time I really talked more about the platform, what that platform looks like to get you from, all right, I have an idea. I know I want to look at AI. What does the platform look like, right? And how can I deliver on a platform and get it to ready to consumption? And that's really what we focused on last time. This time, imagine the platform is in place. Okay, so if you missed the previous episode, what's going to happen is you're going to be lost if you continue down this path. I would go back to episode 11 and even previous episodes around NAI and go through that series because it's going to kind of walk you through the start of it, right? How to actually use NAI, how to consume it, how to actually deploy it, the options and how you can consume, whether it's a full stack solution that we have with Nutanix or running NAI as a software platform service, right? Running on bare metal or any Kubernetes platform or in the cloud. Okay. And in my environment, I'm running the full stack solution running on Nutanix. I'm going to map this out here really quick for you. And then we're going to talk about how to connect the tooling back to the model endpoints that NAI is serving. And the reason why that's important is because you're going to need access to models, right, for these tools to be leveraged, right? And what I like about these tools is a couple things, okay? Um, the first is it gives you an idea of what's possible. And I think that's extremely important. The art of the possible to me is extremely important because you don't know what you don't know. We're all like this, right? And sometimes we need to look at things that people have built to kind of give us an idea of, oh, that makes sense. Maybe this type of workflow, right? AI workflow works in this process or can tackle this process that I need to kind of look at in my environment. Or maybe it's as simple as I want to provide a chatbot on my website. Or maybe it's as simple as I have internal support team and I want them to have access to support tickets, like we do at Nutanix, and cases, so I can lower my time to resolution. And that in turn provides better customer service back to my end customer, right? So these are the things that I want you to start thinking about, but also even complex. And I'm going to show you a tool called N8N. And if you haven't used it, it's pretty remarkable. N8N has a vast, or excuse me, a broad ecosystem of people that are building these AI workflows. Some will be called agents. I'm not going to get into the conversation argument around whether N8N is really an agentic workflow or can provide an agentic workflow in a real sense. What I'm talking about is the very foundation of your AI journey. Okay. Again, this isn't about whether you should be looking at agents or these other new things like, right? I want you to start thinking around where you should start, right? Where you can start providing value. And more than likely that may not be agents or agentic AI right now, right? But at some point you're going to get into that, right? So again, I'm trying to distill the noise for you guys and gals. And I don't want you to really be, drowned by all of the noise that's out there. I want you to have more of a focus on what we can deliver from a usability perspective. And again, using some of these tools will help you start down that path. Now, I'm not saying that these tools are going to deliver you an end product, but it can map out or get you to validate, right? Like a POC or a use case as an example, or even look at a workflow, right? And then you bring in a partner like a data robot, right? or a Kodo or these partners, right, that can come in and really map out what it is you're trying to do from an application layer, and then tying that back into your endpoints, right, your model endpoints. And so that's where we're going to start today. And I wasn't going to whiteboard because I know the whiteboarding hasn't been great, but I think I have to do this to kind of give you an idea of what we're going to cover today. So, quickly, right, we're going to talk about what I have set up, and it goes back to what we did before, right? It's this platform that's in place. And again, it doesn't have to look like this. I think what's important is the top layer here, okay? And the top layer is basically, um, excuse me, is basically what we're providing you from a serviceability perspective. So here's NAI, which is Nutanix Enterprise AI, and we're providing, at the very core, we're providing model endpoints. Okay. And underneath this is the infrastructure and the data services, right? So and what that means is it's the accelerated compute, it's the data services, right? So I'm using NUS, which is our filer service that actually stores the model. Okay. I'm also using NUS as a read write many PVC storage for my applications and for my Kubernetes containers. Okay. So that's another reason why I've deployed that. And of course, underneath this, right, you have the underlying hardware, right, which is accelerated compute. So we'll just call this Excel compute. And I have an NVIDIA L4 in my server, okay? And the infrastructure, by the way, also contains, all of the Kubernetes layer, right, the virtual machine layer, etc. So it's a culmination of all those things that I showed you in previous episodes, with NAI layered on top as a platform service, running on NKP. I'm going to show you what that looks like. And then I'm servicing models. Okay. Now, over here to the left-hand side is how I want to connect to this, right? So let's go here and we'll say apps, right? These are my apps. So the apps we're going to talk about today is AnythingLLM. Okay. Simple apps that you can deploy on a Windows machine. Okay. Very simple. We're going to talk about N8N. Okay. This is more of and FlowiseAI. Both of these are more along the lines of AI workflows. So this is more of a local app. Very powerful, by the way. And we'll get into that first. That's the first use case. We're going to get into N8N and end on N8N and FlowiseAI. And what these are really fundamentally are AI workflows that you can build. Okay. But the reality is all of these things have to connect back to models. Okay. And what are we doing with NAI? Well, we're serving models at the end of the day. And we're serving models via an open AI API endpoint. Okay. That's what we're doing. And we're connecting these solutions back to the models. Now, one thing you're probably thinking about is, well, Mike, I can just connect to a SaaS model if I want, or I can connect to some sort of SaaS offering, whether that's or I can use Open Router, right, and I can connect to other different SaaS offerings. Now, there's a problem with that though. The problem is cost. We talked about this in other previous episodes. So again, if you're at this episode and you're just starting out here, I implore you to stop. This will be recorded. You'll be able to go back to it. It'll be on YouTube and LinkedIn. Go back to the previous episodes where I actually show you using SaaS offerings. Every time you hit the API endpoint, you're being charged. Okay. In this case, I have a solution where I can use any open source modeling, right, that's compatible with NAI, whether that's Llama or models from Mistral or NVIDIA NIM, right, or custom models. You can service all those through NAI. Okay, and I'm going to show you a little bit as a reminder of what that looks like before we get into connecting the applications back to the model. Okay, so this is really what we're going to focus on today. I'm assuming that you've already gone through some of the earlier NAI episodes. Again, if you didn't, go back. Now, one thing I didn't do, of course, is, and I should be doing this every time I forget. Let me just go back here. If you are watching on LinkedIn and you want to go through the chat, or you're having a lesser experience from a video quality perspective, I would recommend that you go to the YouTube channel. Here's the link to today's video at the bottom. So I'll keep this up for a few seconds. But essentially, you'll be able to actually click that link, go to the YouTube video. Again, it's my belief and my view and what I see visually, right, that YouTube has better codecs and the quality is better. So if you're looking to look at a higher quality video, I would recommend that you go to YouTube. Okay. You can also interact with chat. Okay. Now there is a delay. I told this before. I think it's about a minute delay, so I won't see your chat right away. So if you have a question, a live question, I should be able to answer it in chat, and it'll come up on the chat overlay that I see. You won't see it, but I will see it. Okay. So let's go back to the share. And now that you see that what I'm talking about here, let's get into the application. So we're going to start at the very core of the environment and how NAI is configured. Again, this is just a refresher. This is NKP, which is our Kubernetes platform. And you can see here I have, and let me make this bigger because I know it's probably doesn't look great. You can see here I have 5 clusters. Okay, so I'm going to go into View All, and you can see here I have a bunch of clusters, and I'm going to scroll down to NAI cluster. Okay, so this is where I'm housing the NAI application, the service, not the application. I'm going to show you what that looks like here in a minute. But this is the NAI service, and it's running on NKP. And you can deliver this and install this through the application catalogs that are built within NKP. And again, I'm not going to go through this. This is something I've already gone through. So let's go to my workspace, and I'm going to click the AI workspace, and now I have access to NAI, and now I have an NAI cluster. And what does this cluster look like? So let's look at the details of this cluster. Okay, I basically have a cluster that has 3 control plane nodes and 4 worker nodes. Okay, one node pool, 3 worker nodes, and 1 node pool of 1 node with a GPU. Okay, and I'm running NKP Ubuntu. Okay, as the node OS image, and you can see here as I go down to the node pool, here's MD01, and I go to the GPU node pool, I have a different node image that has GPU acceleration drivers, etc., already built in. Okay, so the NVIDIA drivers there, all those things. As part of the prerequisites to install NAI, you have to have Istio Service Mesh, Knative Serving, the NVIDIA GPU operator. Okay, that's all delivered through the application catalog. Again, I showed you this before, but I'm just going to quickly show you this again. And Prometheus, by the way, that will automatically. So you see here, Istio Service Mesh is enabled. The NVIDIA GPU operator, Knative is enabled. All of those things are enabled. Okay, and when you deploy this, you do those things first, and then you come up here and you deploy the Enterprise AI. Now, I have not deployed Enterprise AI through the application marketplace. I have an older version, which I've upgraded over time, and I have not done that. So I do plan on doing that to show you, walk through that process to show you exactly what that looks like, to see how easy it is to deploy the service. But at the end of the day, you'll deploy this last, and it'll actually deploy the application, and now you have a service. Okay? Now, in my service is called nai.utech.local. Utech.local is my domain. I do not have real certs, okay? So I will tell you that the fact that I don't have real certs does give me challenges, especially around FlowiseAI, because FlowiseAI, there isn't a way that I know of right now to bypass the certs, even though you can look on Perplexity and ChatGPT, it'll give you an answer of, oh, you could use this, use these environment variables in your deployment spec for your locally hosted FlowiseAI version, which should allow you to bypass SSL. It doesn't work. Okay. So I'm going to show you another environment that has real certs. Okay. As far as the SSL is configured, and I can show you what that looks like and how you would set up FlowiseAI. So first, we're going to start with AnythingLLM, which is a locally hosted application that you can download and install. There are other applications out there. AnythingLLM I like a lot. I'm going to show you why as I walk through it. Quickly, I do have models downloaded. You can see here I have a bunch of models from different developers, NVIDIA, Meta, Google, Mistral AI. So I have the option to leverage all these different models. Again, this is the power of one of the powerful things around NAI is the ability to leverage all these open source models, tie into Hugging Face repository, tie into NVIDIA NIM, right, repository, or upload your own models, right? You can see here as you import, I tie into these two, and I can use a manual import as well. As a matter of fact, this model here, this Mistral Nemo 12B Instruct was a manual import, okay? And that's why it has a exclamation mark here, okay? And you can see here I actually have endpoints already configured, right? So basically what an endpoint is the inference service being stood up, right? And that model being fed into the GPU memory, okay? And it's ready for consumption. So what we had, and I'm simplifying that a lot, by the way, but the beauty about NAI is it's orchestrating all this for you with the Kubernetes layer. This doesn't work without Kubernetes, by the way. Okay, you have to have a Kubernetes layer. I'm not saying you have to have Nutanix Kubernetes, but you have to have a Kubernetes layer. It could be OpenShift, could be Rancher, could be Tanzu, et cetera. It doesn't matter. Okay, the reality is we're using Kubernetes, right, to orchestrate all of this. That's why if you go to unknowntech.io, which is the sponsor of this Architect podcast in my blog, there is an article about why Kubernetes is the operating system for AI. Okay, and it really has to do with the scaling, the orchestration pieces, all of those things. Now, I do have one model that's active. Okay. The others are hibernated. So this is another beauty about NAI is I don't have to, if I'm done with the model endpoint for now, I don't have to delete that endpoint. I can just hibernate it and then bring it back when I need it. So if I wanted to, I could hibernate this model and I could resume, right, any of these hibernated models, and it'll happen very, very quickly versus having to stand up a new, a creation of a new endpoint and go through that workflow. Okay, this is what I love about this. I have one GPU, so this helps me a lot. Okay, when you have one GPU and you won't have this in production or even probably POC, you'll probably have multiple GPUs. So you'll be able to service, you'll be able to have many more active endpoints than I do, but I have one GPU, so I'm bound to that. And I'm running an Epic server, not an Intel server. If I had an Intel server that supported AMX, I would be able to have other endpoints stood up that support AMX. Okay, that's also supported through Nutanix NAI. Okay, I have an Epic server, however, an AMD server. All right. The GPU I have again is an NVIDIA L4. I think I mentioned that. L4 is not officially supported with NAI. It's not really a enterprise grade GPU from NVIDIA. It's not. And the reason why I say that, and people will argue about this because they're like, well, no, I see a lot of videos out there with other players like Serve the Home and Storage Review and all these, right, where they're putting L4s into edge use cases. And I get that. The problem with that is you're very limited in what you can do with an L4. Okay, so for example, I can't use, barely any of the NIM models, right? Because the NIM models really are focused on, especially now, they're focused on typically L40S and greater. So L40S, H100s, B200s, GB200, NVL, F72, Blackwell, of course, the Blackwell 6000 Pro GPU, which is getting a lot of attention, that has 96 gigs of memory and it's very, very fast. And they have a couple of versions of that. They have a server version, a workstation version, and they even have a trimmed down lower wattage version for that GPU. Very expensive, between $7,000 and $9,000 for that GPU. So I can't invest in it. The L4 when I bought it at the time was, I want to say, $1,300. The L40S has actually become much more reasonable. It used to be around $12,000, $13,000. I see it now for $7,600. I just looked at it the other day. Wired Zone, I believe, had the L40S for $7,600. That's not bad at all. for if you want to do pass through, right? If you want to do other things, obviously you have to buy NVIDIA licenses, like the vGPU side of it, right? Um, and I think what I'm going to do too is I'm going to, I've been really focused on NVIDIA enablement. I just took the entry level fundamentals AI data center infrastructure exam in the course, and I thought it was very good. And I'm going to do a whole section on NVIDIA. I think in the next episode to really focus on where NVIDIA is, and it really is. It's the silicon, which is extremely important. Everybody talks about the silicon, right? And that's really where their money is being made. But there are three other pieces to this I think that matter. And I just did a LinkedIn post. If you go back to LinkedIn, did a post yesterday on this. Is the CUDA, right? Parallel and programmable framework, right? That you can deliver well advanced, well more advanced than any solution out there. Okay, AMD is ROCm. Intel, I believe, has Gaudi or has other things, but they're so far behind when it comes to CUDA. Believe me, I hope that AMD, et cetera, they start coming to the fray as far as these parallel programmable frameworks. But CUDA has been around for a long time, and it's very, very advanced. Then you have the side of the NIM, right, and NEMO models, and then the blueprints, right. So if you culminate that with the silicon all together, and then layer that on into Nutanix Enterprise AI, you have a complete platform, right, that has simple to use blueprints, right, the CUDA framework for parallel processing, all of the great silicon that NVIDIA provides, but Nutanix orchestrates all of that. And I think that's what's missing from the NVIDIA side is the orchestration of all those pieces, parts. I mean, primarily they're a hardware company. Let's silicon company. Let's call it what it is, right? They're now putting effort into. I wouldn't say now, but they've been putting effort into beyond CUDA, but also into their NIMS and NEMO models, right? Reasoning models. The fact that they take an open source model and they enhance it and give you enterprise support, that's phenomenal. I love that. To me, that's a very telling story. And then provide blueprints. The problem with those NIMS and NEMO models and blueprints is you really have to know what you're doing to stitch all that together. If you add that to NAI and the ability to orchestrate all of that, that's where you can see a real platform come to fray. Okay. Now, I went off on a tangent, of course, which I always do, but that's what I'm going to be talking about in the next episode. Really focusing on NVIDIA and where NAI and NVIDIA can really deliver that unified platform capability. Okay, so you see here I have an endpoint. It's based on the Llama 3.2 3B instruct reasoning model. Again, I'm bound by the GPU memory I have, and of course the time to first token and the tokens per second. Right, I want to make sure this is a good experience. So I'm using just a 3 billion parameter model. It is a great model, though. I can't use the NVIDIA version of this, unfortunately, because it's not supported on the L4. So regardless, let's get into what we're going to do. So you see I have the endpoint, and now I'm going to launch AnythingLLM, which is basically just an application running on my desktop. And I have connectivity back into my endpoints, okay? So this gets a little kludgy because you may have an environment where you're not going to just have your desktop and then all of a sudden, you have access to your backend data center. That may not be prudent for IT. So they may provide you maybe a virtual development environment or something like that sits in the data center where they can provide that connectivity, or they could provide connectivity. I mean, I'm not saying they couldn't, but in most enterprises, this is locked down. Okay. So you can see here I have Anything LLM. It's basically a basic install. And I'm going to go click the wrench here, and this wrench is really around the Anything LLM instance settings, and you can change a lot of these settings, but we're going to focus on the LLM settings. And again, you have all this access to these models which you can download and store locally, but I want to be able to see the performance of these models, right? I want to be able to gauge the performance. I want to be able to life cycle the model, right? I want to be able to provide access, and that's reality in the enterprise. Okay. People say, well, why don't I just download Olama and test my models that way? That's fine. You could do that. You have no governance, none of that, right? To me, that's not shadow AI in a sense of cost, but shadow AI in a sense of not giving you a full service, right? you're gonna have to build. You would have to build all of the pieces to kind of give you like the observability stack, all of those things, so you understand what kind of performance you're getting, what the latency looks like, right? We're going to provide all of that via NAI, right? And I think that's the beauty of it. And plus, it's an enterprise grade solution running on an enterprise grade stack, where Olama is just you're just running it locally on your machine. Okay, so anything LLM by default uses anything LLM providers, but you can use, if you scroll down, a custom, or excuse me, generic open AI endpoint. Okay, and you can see here that I have a base URL, which is my NAI. Remember, I said my NAI API or URL is nai.utech.local. And if I do /APIs /v1, that is the address that I need to connect to the model, to the endpoint. Okay. Now I also have an API key that I provide, and that's built within NAI. So if you look at this instance, you can see here I have an API key called HF test. I've created this API key already, and you would do that within your environment. In previous sessions, I showed you how to do that. So I would urge you to go back and look again. Don't go into this thinking that you can just stand up NAI and connect N8N or FlowiseAI or anything LLM back to this. You have to understand how NAI works first. Even though it is simple, I gave you a simple kind of view on how to deploy this and how to actually operate it, right? It's very simple to operate. So you have API keys. I have HF test. And that API key is what you would put, excuse me, what you would place in this field here. And then the chat model name. Now you can see here, this is LL32-1B. That is not what I'm using, all right? I'm using 32, and we got to go back. This is the endpoint name. That's what I have to put in there. So I'm going to copy this, which is LL323B instruct. And I'm now going to go back into anything LLM, and I'm going to paste that in here. So now I have the URL to my endpoint, the API key, and the model name. Okay, so now I'm going to save changes in the upper right-hand corner. And you can see here down at the bottom, it says it's saved. Okay, so now we're going to test this. So let's do a test. And I should have cleared all these, but I'm a Star Wars fan. Matter of fact, I'm wearing the Star Wars shirt. You can see here I have all the stormtroopers here. But let's just ask a stupid question like how many laser cannons are on the Death Star. Now I'm just using the basic model served by NAI. Okay, so you can see here there are a total of approximately 21-25 laser cannons on the Death Star. Do you believe that? We've all seen the movie, right? So this goes back to the accuracy of a model without having your data, right? And this is just a simple test to say, okay, I have a model, I can connect to the endpoint, I know that my model works, and you're probably like, well, how do I know I'm using that model? All right, well, we're going to show you. Let's go back in here, and we're going to go back into the dashboard. And I'm going to choose the last 24 hours, we'll say. And you can see here, I have these requests that are coming in, okay? And this is how you know you're using the model, because there's applications coming in and hitting this API, using this API key, right? By the way, you could say, well, if I had one API key and I had all these apps hitting the same API key, I wouldn't know what app was hitting it, etc. True. That's why I would recommend creating an API key for different apps, right? That way you know what app is connecting. In my case, I only have one API key defined, and I'm going to be using it for all of the tooling I'm going to show you in the integration tooling, okay? But essentially, I'm showing you basically exactly what's happening, right? And this actually was the most recent request. I did one request. It was successful, right? And generally speaking, it tells me if I have problems as well. So if I go down here and I go to models and I go to the endpoints and I go to the actual endpoint, I can actually get a little bit further in to see exactly what's happening, right? So I have one configured endpoint, one request that just came in. That's the one we just did. And you can see here at 11:28, right? This is my request coming in, and I can actually provide the latency, okay? Now, in the next version of NAI or in future versions of NAI, you're going to see time to first token, tokens per second, all of those things, Okay. Now, these are things that I talked about. Matter of fact, I was just having a discussion about this yesterday with a peer of mine who works on this product or the integration with this solution. Right. Um, Phenomenal resource. Love talking to him. I hope one day I can get him on the pod because he's just a great resource. I hope he comes on. Um, Regardless, those are some of the things that customers have been asking, right? They want to know how many tokens per second. They want to know what time to first token looks like, all of that, right? Other tools provide that, right? Like Olama, for example, is very easy. It provides that. You can go in, you can see time to first token, how many tokens per second you're getting, etc. Okay. And other things like KV cache. We didn't talk about that. It's not just about the model. That's just about the GPU memory supporting the model, but also having enough memory and GPU for KV cache as well. Because KV cache actually, remember, if you go, what KV cache does is it's retaining the cache, the context of your initial request. It's retaining that, and then subsequent requests. So it's retaining that memory, right? And of course, over time, as long as you're talking about the same context. So, for example, if I said how many laser cannons on the Death Star, and then I say, can you expand on that, on how many laser cannons are on the Death Star, or can you give me more details about the laser cannons? It knows that it's part of that initial um, question, right? And because it's stored in KV cache. But then when you ask a completely different question, that KV cache is done, right? It starts over again. That's why you need memory, right? Whether that's, and we're going to show you what that looks like and some of these other tools. That's why you need memory, like a database or something like that, to store those previous requests that you had. Okay. Now I'm getting off in a tangent again, but I kind of want to give you an idea of how this works a little bit. Okay. So let's go back to my request. Now, I want you to think about this in terms of your environment. So say one of your use cases is I want to be able to chat with docs, or I want to be able to obtain information very quickly, or summarize information, or create something, generative AI, generate something, right? A report or something like that out of the data that I own, right? The model doesn't know my data because it's proprietary and private, and I haven't provided that data for the model to be trained on. Okay, so I'm using an open source model that was trained on world data. Okay, and world data, when I say world data, I mean publicly accessible data. Okay, and a lot of it's synthetic data too, but you're starting to see synthetic data being used as well for training. I'm not going to get into that, but the reality is what's happening, especially like in these larger frontier models, right? They're running out of data, and so they have to use synthetic data to actually train on. Okay. Different topic. I'm not going to get deep into that, but you have data, right? And you want to be able to make sure that you can use your data to enhance the experience. So let's assume that your business is building the Death Star. I know it's stupid, isn't it? But it's a funny kind of remarkable example. And you have plans. You've built these plans, and you stored these plans somewhere. And I want to be able to my team to be able to access those plans or information about those plans at any point in time. Well, you can do that through what's called retrieval augmented generation. Okay, that's one method. And by the way, there are new ways of doing augmented generation as well. And I'm not going to get into those either. Those are subjects at another later time. But at the very core, what you're doing is you're feeding your data, right, to be used, right, in the application. All right, so this is your chat application. LLM is kind of simulating your chat application, connecting back to your open source model, and now you want to add data. So what we're going to do is we're going to create a new thread, and you can see here at the bottom I have upload document. So within this upload document, I'm going to add a document, okay, just as a proof of concept. Now, this is not how you would do it in production. This is proving out if I add my data, do I get value out of this, right? And so I'm going to go in and happen to have a Star Wars folder on my NUS drive, and it has a whole bunch of information. One of the pieces of information is a Death Star technical companion document. Imagine that. So we're going to take that, and we're going to do something very, very quickly. I'm going to walk through what this looks like later when we get into the FlowiseAI portion, but that really shows you what real RAG looks like. This is real RAG, but it's a simulation. It's simulated basically, right? It's not something you would use in production. I'm going to move this document into the workspace and I'm going to save it and embed it. What is this doing? It's taking that document and it's chunking the document, right? It's basically, chunking it into pieces and parts. Okay. Then it's storing that into a vector database. Okay. That way it's easily accessible. So when I ask a question, it's going to go against the vector database to see if we have the information, and then go back to the world model to determine the best course, the best answer for you. Okay. So now that that's done, and I have this document embedded, I'm going to now ask the same question. How many laser cannons are on the Death Star? Asking the same question. You can see here I'm getting much more granular information versus what I was asked before. So let's go back to the first request. How many laser cans are on the Death Star? There are a total of approximately 21, 25 laser cans on the Death Star. When I actually embedded the Death Star, technical document, okay, based on the provided context, the Death Star has a total of 6 laser cans, 2 twin laser cans on cargo bars, 2 laser on the TIE bomber, and 2 heavy laser cans on the repulsor tank. So what it's doing, as you can see in the citation, is it's pulling this information out of the document I've uploaded. Okay, so it's saying, okay, I need to have much more, I can provide much better granularity back for this question. So this is a simple use case. So I want you to imagine where you would use this. Think about the use cases where this would make sense. Okay. Maybe you're maybe you provide support back to your customers, right? And you wanna provide better customer service, lower time to ticket closure, those types of things. You have documented cases of resolution and problems. Okay. So imagine those documented cases and are constantly being uploaded through a workflow process, okay, an ingest process into this that actually does all of this for you, does the embedding, does the chunking, the embedding, right, puts it into a vector database, okay, and you're continually feeding new information into this environment because again, you're not just going to feed information into it once. Your information constantly changes. Matter of fact, if you're running a support organization, you may have your tickets are, you have multiple tickets, there's multiple resolutions, new questions, new responses, new resolutions, right? So you want to be continually ingesting that into the environment so you can take advantage, your customer support or SRE team can take advantage of that. We do that at Nutanix, okay? And it's resulted in a lower time to ticket closure. And that results back into better NPS, better customer satisfaction. Okay. So that's one example. Another example is you're a legal firm and you have a ton of documents and you just don't have the staff, or you want to augment the staff and lessen the time to do research and those things. So now you have a research environment where you can actually dig into the legal documents that you own and you have. Okay. Those are just two examples. Maybe you have a chatbot on a website and the chatbot answers questions about sales, return policies, support, those things, right? That chatbot has access to tools, okay? Now, one can say that the chatbot could be an agent and has access to these different tooling. That could be probable, right? I'm not saying you can't go down the path, or even with the path of the research agent, or excuse me, the research use case for the legal firm, you could build agents to do that, okay? And you can maybe create contracts, or maybe maybe you're in procurement and you need to look at contracts or those things, right? Or you're in HR. Here's a simple use case I saw the other day. Very, very simple. I'm a recruiter and I ingest thousands of resumes constantly, right? Maybe I work for a very popular company. Maybe I work for AWS or something. I'm a recruiter, right? Or I work for NVIDIA or a big company, right? Cisco, etc. They're not possibly looking at all those resumes. Something's doing that for them to weed out the valid resumes and the invalid resumes, right? The personas, okay? And you could do that. You could build something like that for HR as an example. I mean, again, these are just examples I'm just floating out there, right? You don't have to, use these examples, but That's what I'm talking about. Thinking about like these problems where there's time consumption, where you can save time, or you can provide a better service back to your customer, or you're augmenting your workforce. These are the things you should be looking at right now. Okay, because these are things I think that we see, not I think that we see in the enterprise where quick wins are happening, where real ROI is coming out of it. That's another thing that I talked about in my LinkedIn post. The 5 blockers. One of them is ROI. No one really knows what the ROI is. If you can't get the ROI out of it, then what good is it, right? It's a solution you're trying to you're ultimately trying to get ROI out of it, right? So that's what you have to kind of look at. So this is just a very simple way of tying in anything LLM, right? Validating it with a possible use case using your data, right? And this is like a proof of concept. So you're just getting ideas about how this works. And again, you can go back to NAI and you can look. You can see here again, 1137. That's when I just did that anything LLM test. You can go back and look and see. I have another successful request. What's my latency? And again, you're going to be able to get more granular information around performance. Okay, when we go to the dashboard, you could look at your infrastructure summary, get performance metrics, GPU, right? You can look at the GPU, et cetera, right? So you have all this different metrics to look at and monitor and have lifecycle management over these models. What if I want to change the model? Well, I want to change the endpoint. So I basically maybe hibernate this and I want to look at a different model. Maybe that model wasn't giving me enough value back, right? The response wasn't good enough. Maybe I want a larger parameter model like a 8B, 8 billion parameter model. You can see here, I can activate this, hibernate that, activate this, change the model, right, on anything LLM and try it again, right? Let's do that. Let's actually do that. Let's hibernate this. So we're going to hibernate this endpoint, and I'm going to now go to a 318 an 8 billion model here, and I'm going to resume this model, and you can see here it's pending, and basically it's standing. It's basically when I hibernated it, basically turned down the inference service pod, right? And now when I resume the new model, it's loading that model into GPU memory, standing up the inference service endpoint. Okay, so when this is ready, we're going to go back into anything LLM. As a matter of fact, we can do some things now. We know the name of it. It's still using the same API key, even though you wouldn't do this in production. I made it to do it easier. All right, I can go back in here and I can change this to that model. Okay, and I'll hit save. Let's see if the model's ready. It's not ready yet. It's processing. So again, it's feeding this model. This is a bigger model than the 3B. This is an 8 billion parameter model. And this is the one we were using was a 3 billion parameter model. Now, again, I'm using an NVIDIA L4, so it's not the fastest, right? The memory bandwidth is not the greatest. If you have an L40S or an H100, it's by far much faster and much larger from a model perspective. So I think the L40S is 48 gigs of memory. So you'd be able to load models, not 48 gig. Everybody's like, oh, I can do a 48 gig. No, you still need to have memory for KV cache, right, in the GPU. You can't supersede that. So you want to make sure you have some memory for that. But you can certainly do much larger models than I'm doing. I have 20 gigabytes of GPU memory on the L4, and the L4 memory bandwidth is nowhere near as good as the L40S or the H100s. So this is still processing. Let's give it a little bit. While we're waiting on that, I want to go into another tool we call N8N. So N8N, again, these are more workflow tools. When I talk about FlowiseAI, and I probably won't be able to get into FlowiseAI. I only have about 10 minutes left, 15 minutes left. Let's just focus on N8N for now. So an N8N right now is an AI workflow or an automation workflow tool. Okay, very, very popular. You can actually go to the website, right? And you can discover all these templates. So a lot of users, remember I talked about the community? There are a ton of templates that you can leverage here for different categories and different use cases. Okay, So let's just go into marketing as an example. Summarize YouTube videos from a transcript. Analyze landing pages OpenAI to get optimization tips. Send multiple emails in Gmail directly to Google Sheets. That's content creation. Like, so you have all these workflows that people have created. They could be agentic or they could be non-agentic, right? I'm not saying they're all agentic. They're not. Let's go into sales. So sales is a big one, right? One of the things is like looking at leads. Here we go. Generate leads with, I don't know, Google Maps is a good idea, but generate leads. Here's a workflow. Social media analysis, CRM workflows, lead generation, scrape business emails from Google Maps without the use of any third-party APIs. AI web researcher for sales. Deep research and research agents are starting to become very, very popular as a use case for specific things. Okay, especially around sales, marketing, engineering, etc. Autonomous AI crawler. So again, you can kind of get ideas by going in here and looking to see what others have built and what they're doing. I'm not saying you have to exactly do what they're doing, but imagine being able to. And by the way, you can click into this and you can use the ones that you can use for free, the ones you have to pay for. You can actually click use for free and actually say, bring into my locally hosted NAN instance. By the way, there's also a web version of this, a SaaS version of NAN, but I like to run my stuff locally because I want to make sure that my IP is protected. That's one of the reasons why you do things locally. My IP is protected, my data is protected, right? And I'm not using SaaS solutions, right, from a model sourcing perspective, so I don't get hit on that cost every time my model gets accessed, right? My endpoint gets accessed. So again, just an idea. Let me go back to now. You see the model. I want to just go back here. I mean, I'm moving around a bit. Let's just go back really quick and change this up. So now I'm on LL318B, and I want to go back into anything LLM. I already changed this. Let's just do it one more time, just to make sure, because sometimes if you do it before the model is available, it'll error out. So let's go back. Let's ask it again. I'm going to ask the same question. So you can see here it's taking a little bit more time, and you can see it's a little slower in answering, okay? But it now has an 8 billion parameter model to go against. And of course, I'm using the Death Star, so I may have a better accuracy here, okay? The fact that you can tell just by how it responded that the tokens per second were much lower than the 3 billion model because of the fact I'm using the L4 GPU, okay? You guys have to kind of test the waters in these models and what makes sense, right? Because you need to figure out at the end of the day what models are the best models for the use case that you're looking at it for, okay? And that's where the POC pilot testing validation comes in. And what's great too about working with partners like a Data Robot, they'll be able to tell you where they see the best value, right, for specific use cases. So because they're doing use cases, and I know every customer is different, but a lot of the use cases are similar, and they can say, oh, we see that customers seeing much better value out of XYZ model for this use case from a cost, right? And it goes back to what I talked about before: tokens per dollar, right, per value, per outcome, or excuse me, per outcome, right? That's the goal. The goal is to get the right token, amount, the right response, the most accurate information at the least cost, right? That's the goal. So you can see here it's a little bit different, right, of an answer because of the 3 billion parameter model. All right. Okay, so let's go back into N8N, and I created a simple chat workflow, right? And they call it an AI agent. I'm not sure if it's an agent because to me, an agent is more autonomous than it is. And what is an autonomous agent? Autonomous agent basically is like a human, right? So imagine a human. I have a task in front of me I need to do. I have my brain to reason around what I should do first, where it makes sense. And then I have all these tools I can access, whether it's the web or software or whatever, right? I have all these tools that are at my disposal. That's where we want the agent to go with, right? The problem is what are you trying to solve? right? You have to have some sort of context for the agent to understand what it's doing, right? And so whether that's an automation that happens, a trigger, whether that's a Google sheet that's fed in. So let's talk about example lead generation. Maybe you want to go through, you have a report of leads and you want them to do research on the leads and maybe send an automatic email to the leads as an example. Well, you'll feed that report in to the agent and the agent will take that and run with it, right? Based on the context of what you describe the agent needs to do. All right. And the agent has tooling like where it does research. In my instance, I have SERP API. You can see here to the right. SERP API actually uses Google search. Okay. Now there's a cost to this. I'm going to show you this in a minute, but I get free. Everybody gets, if you sign up for SERP API, you get 100 free searches a month. And I'm already at 30 something. So I have to be very careful here. And I'm using simple memory. Again, this is simple memory that I can add. This goes back to what I talked about with KV Cache. I don't have to worry about this because I have simple memory now, understanding what I can continue to ask different questions, go back, and I'm storing that in memory. Generally speaking, this would be a database in production. And so you would be able to kind of go back and forth around what questions you're asking, et cetera, and not have to worry about it, the model having to think about the question. So for example, if I say, and we're going to do an example here, if I say, can you research the prices of give me the top 3 lowest prices of this product, right? And then you go to a completely different question. Describe this product, right? Well, in KV Cache, that would be gone because it's a different question, totally different context. Okay. Now that I have simple memory, I can go back to that because it's actually storing that. What does an agent need? It needs memory. Remember, an agent's like a human. It needs a brain. It needs memory. It needs compute power, right? It needs the model. And it needs tools, right? And it needs a purpose. So those are the 4 things kind of what an agent needs. It needs purpose. It needs access to the brains, right? The reasoning and the safety and all those things. It needs memory to remember what it's doing, right? And it needs tools. That's what we do when we go to work, right? We have those things to work with as a human, right? And we have a purpose. We have reasoning, right, in our brain, right, just naturally through how our brain functions. We have access to tools, and we have memory, right? Now, again, I built this. You can actually build this very simple. All you're doing is you're adding a chat, a chat instruction, and then you're creating an AI agent, and you're defining what the AI agent does. So if we go into the AI agent, I have a system message, right, which basically the context, right, and I say you're a real-time AI assistant with live search capabilities. Whenever you receive a query requiring up-to-date information, and this is spelled wrong, not a big deal. It's pretty smart. Information, I still can't spell. Use the Google search SERP API tool to fetch the latest results before responding. Okay, so that's the agent context. And now I'm using the model, what model I'm using, and you can see here I have an account. So let's go back here, credentials. And if I go back to personal, you can see here I have credentials. I have an OpenAI account and a SERP API account. So let's just talk about OpenAI account. Remember that we use OpenAI API, compatible API, right, with NAI. So I'm using this OpenAI account, but I'm pointing to my local instance of NAI, okay, and my API key, the same API key that I used in AnythingLLM, okay. So if we go back here to the workflows, right, that's what this is configured with. Now this is using the 3.2.3b instruct. I'm actually going to change this back to the 3.2.1b. Let me just make sure it's right, because if it's not going to work. Yeah, it's the 3.3.1.8b instruct. Let me just make sure. I may have not set this up. No, it's right here. So I'm going to click this, and now it's using this model, okay, because it knows the models that I have available. I have simple memory set up, and I have SERP API set up. So I have a credential for SERP API. It's using the SERP API account, and I actually am logged into SERP API dashboard to show you exactly what it hits, okay? So this is the tool that I'm using for this agent. And I use the term loosely because it's not really an agent because it's a workflow. Okay. It's simulating an agent as best as I can through an agent. And this is a very, very, very fundamental foundational type agent or workflow. Okay. So let's talk about what is the current state of AI. Maybe this is a research agent that you want to build right in your environment. And by the way, yeah, sometimes this takes a minute. Let me just ask it again. What is the current state of AI today? Yeah. Sometimes it takes a minute for that to the change for the model to take place. Okay, so be a little bit patient with N8N. Sometimes it takes a little bit, and I apologize for the dog. I have people outside, probably mailman, probably. But essentially, what it's doing is it's using the OpenAI model, and then it's going back to SERP API to scrape the web and get the most relevant information, and then it's going to deliver it back to me. Okay, so it's going back and forth, and it's basically iterating on this, and it's going to provide me information. So there are sometimes you'll see max iterations and it won't come out. Of course, I'm doing a live demo, so of course this is not going to work, right? But essentially, it's the same. Let me just ask it one more time here to see if it works. But essentially, it's kind of the same thing, right? If we go back into Enterprise AI and I refresh the endpoint, you'll see here at 11:57, right, that these requests are coming in. And you can see here there was a failed request. You can see here there's successful requests. So again, you're able to leverage an AI models. You can see here how I changed the model, how easy it was to change, how I'm able to monitor it. But going through here, okay, so you can see here that it gave me a basic answer, right? Based on the search results, the current state of AI is rapidly advancing with significant adoption among large companies, individual use of general AI increasing in 2024. Okay. So I probably didn't wait long enough for the model to take place, to connect, et cetera. But essentially it worked, right? You now have a response. So with N8N, you're able to do the same thing, except it's done a little bit differently. Again, you got to go through the credentials piece. Create your credential. Your credential is your OpenAI connection back to NAI. You're going to use the API key. And then when you do that, when you're in the actual model, or excuse me, the model itself, you're going to choose the list of available models, or you can type it in. Okay. And you can see here, I just basically got the model name and I pasted it in from NAI right here. Okay. Very, very simple. Now I'm up in time, unfortunately. Of course, I like to talk, as you know. But this is just, briefly how you can use third-party tooling like AnythingLLM, N8N. FlowiseAI is similar, but FlowiseAI requires SSL, so you definitely have to have SSL connectivity, which you would in production, or even a POC, you would have SSL. You'd have a certificate set up. So, don't look at mine as the this is what production looks like. It doesn't. I mean, again, I'm on a single node. I'm running Community Edition, right? Nutanix. I'm running an L4 GPU. I don't have SSL set up. So it's like this is just more around functionality demo versus how you should do this in production. We actually have NVDs, and I talked about that in the last episode around NVDs and how we have validated designs and how you would actually put this into production. Okay. So I think that's it for today. Again, I think the next episode, I'm really going to talk and get deep in NVIDIA. I'm going to ask Jesse, hopefully, I hope he comes on the podcast because he's just one of the great minds in our organization that I love talking to him about this stuff. I hope he would join me on one of these. So I'm going to try to get him if he watches this and he's listening. Hopefully we can try to convince him to come on, but we'll see how it goes. But I really want to focus on NVIDIA and where NVIDIA is and how to incorporate NVIDIA right with Nutanix a bit. It's a little bit harder to do that because I only have the L4 right as an example, but I might be able to get access to other environments to maybe see a demo around how you can incorporate NVIDIA all the way through the stack. Whether it's again the silicon, obviously that's the no-brainer. CUDA is being used in the backend. That's the no-brainer. Using NIMs or NEMO models, right? And then possibly talking about where blueprints are allowing customers to really build the solution for the use case and making that much easier. So you basically have a blueprint, foundational blueprint you can implement, and then you can adjust to your use case, right, in your environment. And that's easier from building from scratch, obviously, right? And again, it all goes back to Nutanix orchestrating all of that for you so you can get to value. That's the whole goal, right? ROI, value realization, all of those things are what's important around Gen AI today. So I hope you have a great rest of the weekend, and I'll talk to you either next week or the week after. I'm not sure if I'm going to do one next week. I do have some time off. I may do one on Saturday. We'll see. Stay tuned this week for an update on that. Thanks for joining. Have a great rest of the weekend, and I look forward to talking to you soon. Take care. Bye-bye.